Good evening, everyone. My name is Ahmed Ibrahim. Along with Mukhtar, Mohsin, Abdurrahman, and Momodu, will be presenting on our smart construction site monitoring system. So the aim of our project is to enhance the health, safety, and security within a construction site. Our objectives are to develop a system to monitor the physiological state of the workers, the surrounding environment, and scaffolding of the construction site using sensors, design a system for facial recognition, attendance logging, and personal protective equipment detection, as well as integrate the system through an IoT platform and evaluate the overall performance. So this is our overall block diagram of our system where we have the subsystems using sensors connected to a microcontroller. The information from these systems are then passed through to the IoT platform using a Wi-Fi module. Then the attendance ID logging as well as the PPE detection is then directly done on the IoT platform.
My name is Mohamed Lamin Jalo. I will be talking about the physiological parameter, which is the heartbeat reading, temperature measurement, and body posture reading. This is the flow chart diagram for my system, whereby I will first initialize the Arduino pin and also the Node MCU pins. I'll measure the heartbeat sensor. When it is successful, the data and I read the data from the other sensor, and all those data are transmitted by the Arduino to the Node MCU, and the system it is updated by the Node server through the Node MCU. So this is the component comparison for my system, which is temperature sensor, heartbeat sensor, and body pressure sensor, whereby I choose the NM35 due to its temperature range and also its supply voltage. I choose the Max 3100 oxidometer due to its small in size and also its power dissipator. I choose the gyrometer for the body pressure sensor due to its high performance mode and also its high operating voltage. So this is the design calculation for my system. The heartbeat first, we take a heartbeat of 220 and also the maximum heartbeat whereby the BP is supplied by the age. So the lowest heartbeat is multiplied by 50%, and also the highest heartbeat it is multiplied by 85%, and also the number of beats in 10 seconds equals to the counting times 6, which is 1 minute. We will have the beat in 1 minute. So this is the body temperature calculation whereby 0.1 pound is per degree Celsius, and also the volt is multiplied by 100 for us to have the range of temperature. This is the circuit design for my system, which we have a flex sensor, the heartbeat sensor, and also the L25, which are all connected to the analog pin of the Arduino, and also the output it is connected by speaker. When the person is in a wrong body pressure, the speaker will alarm. Also, when the heartbeat reading and also the temperature reading are taken through the LCD display and also the virtual terminal, which are being sent to the Node MCU through by the IoT platform, which is going to be designed later. Thank you.
Hi again. I'm going to be talking about the scaffold safety assessment. Just a general overview, we're going to be attaching a wireless strain sensor to the columns of the scaffold. The reason why we do this is when the scaffold experiences a load, the columns experience some strain. So depending on the safety condition, the strain data can be obtained. So the flowchart is when we create a model first, and then we analyze this model using various ranges of load for each classification. Then we train the machine learning algorithm using the respective strain measurements. Then we finally obtain input from sensors, and then we can finally predict the safety condition of the scaffold. So this is just the scaffold model, 3D model created based on the specifications and the properties is attached. So the very first component we're going to be looking at to select is the microcontroller. The reason why we selected Arduino Nano is because of the form factor. It's small in size, which can then be used for the wireless sensor. So with regards to the strain gauge, the BF series, ZF series, and BA series are all similar in alike. So we just elected to go with the one with the least variance within the gauge factors. So the op amp, which is essential for the whole system that we selected, was LM741. The reason why is because it has a high gain, as well as the input offset voltage is lower, and the power dissipation is also the lowest. So with regards to the machine learning algorithm, we selected a support vector machine to train our strain measurement datasets because it has one of the fastest times among the comparisons, as well as the highest accuracy within them. This is the calculation done for our strain gauge. So one of the first things that we have to do is attach our strain gauge to a Wheatstone bridge so as to get the change in resistance to output a voltage. Because the voltage reading is so small and the change in resistance is so small, we have to attach an amplifier to it to amplify the signal, as well as the Arduino to be able to read the signal. So this is just a circuit design showing how it looks. This is the scaffold simulation where I've applied some force. Then we're going to obtain the strain measurements and update it onto our data set. Thank you.
My name is Abdurrahman Ali. I am working on security system on this project. This is my flowchart. First of all, I use Arduino Uno on my project. When I will run my program, I will start my program. The Arduino Uno will send all the information to the PIR sensor and GSM and RFID terminal. And this is my component selection. As I said, I use Arduino Uno and GPS module and GSM and PIR sensor. As you can see, all this is different between all of my component. The core speed, advantage, working voltage, disadvantage, and the price. On my design calculation, on GPS module, there is 3 different ways to calculate the location. As you can see, the part A and B and C. And on my PIR sensor, the relationship between observed frequency and obtained frequency. And when my PIR sensor detect any person, they have the 30 to 60-second sleep mode. And my scientific range from my PIR sensor is 6 meters. And this is my simulation part. I connect all my sensors to my Arduino. Thank you for watching.
This is the sample display of our IoT dashboard, where we have our subsystems divided into individual tabs, and we can get the readings from our sensors. Thank you.